Okay, so in the last video, what we did was determine the ideal multiple regression model using several of many tests, such as the BIC, AIC, interaction variables, testing for multicollinearity, all of that stuff. But what we can't forget is that we need to consider if our data has heteroscedasticity. Recall that if a data has heteroscedasticity, that means the variance within our data set is not constant. So we need to test for it, and if it does, then we need to correct. After that, we're gonna finalize our model and analyze our coefficients and um, our overall analysis. All right, so we when we visualize the heteroscedasticity or visualize our data to test for heteroscedasticity, we this the model we used here is a three-dimensional model because it is a multiple regression. And so when I produce the output of this is kind of the output we're gonna get. The very center of the square, it's what's gonna be 0, 0, 0. So like right here, if you can kind of visualize the center, and then the data points like around that move closer to the sides of these squares, those are the ones that move out farther from 0, 0, 0. Now this is a little hard to visualize, so the good news is we have a formal test for it anyway. We've learned that we can use the BP test or the GQ test. Just very simple functions because R is a very powerful software. But we use these two functions, and both of these results show us that we reject the null and that we conclude that there is heteroscedasticity. And because there is heteroscedasticity, we need to correct for it. Once again, there are several methods to correct for this heteroscedasticity. What I've used is the robust standard errors, but I've tried using the weighted least squares, which I think is more common, but I didn't really get the code to work, so which is fine because there are several methods. So using the robust standard errors, we're only adjusting the standard errors, not necessarily making the data blue as linear unbiased estimator. But we adjust the standard errors, and when we output this model over here, we get several coefficients, lots of coefficients. Some you actually see that are negative. Let's see, what's this? Right, so this output right here. So this is kind of the coefficients that we're going to analyze, and the standard errors are now correct because we corrected for heteroscedasticity using this coef function here, using all this stuff. But so the standard errors are correct. The p-values mostly are under 0.05. I know this one is not under 0.05, but it is pretty close to it. So let's just analyze the coefficients for a second. Some you see are positive, and then the other ones you see are negative. Now, you might be wondering, you might be thinking, hey, why are these coefficients negative um, if overall we saw that, intuitively we should think that increasing the land size or driveways or bedrooms should generally up the price, which is true. But what we you have to remember that the interaction variables also come into play because a lot of times the interaction variables can inflate our coefficients. And so these single variables are kind of compensating by like subtracting what these positive interaction variables are calculating. So these interaction variables, obviously they're being multiplied. So the results of the impact of y are going to be much higher than what these singular variables are going to try to do onto the y. So these interaction variables, as you can see, are positive, and then these singular variables are kind of saying, oh, well, you kind of increased these interaction variables, or these interaction variables are a little too high, so let's kind of tone down the impact on y a bit. But overall, it should results should be positive. Usually, you would use kind of like the predict function to kind of confirm our relationship, but just for the sake of time, I'm not going to do that for now. But yeah, we've corrected for heteroscedasticity. We've finalized our ideal model based on a lot of things. Our p-value based on our ideal model was significant, so these are useful. We can use hypothesis testing for these coefficients. The last thing I want to make note of before I move on to time series is these values they're utilized for predicting the prices or predicting future y values, but they're not necessarily directly for predicting. So when we interpret these coefficients, we want to get more of a regression analysis. This is a little confusing, but we're analyzing more of the impact on x on y and not necessarily trying to forecast or predict the values on y, because predicting takes characteristics of a regression analysis, but we also have to utilize other methods like cross-validation and machine learning, all those stuff. So, which I'm going to get in once I'm done with this review project. But for now, we kind of want to see these coefficients and the meaning of this as more of like a regressive into the past, instead of, oh, well, let's try to use this coefficient to predict the future. All right. In the next video, I'm going to go over the time series data analysis, maybe more into the probit logit model. Actually, I'm probably just going to do time series, but yeah, that's what I'll do in the next video.